My name is Craig Kimple, and this is a demonstration of the Process Analysis Tool, an enhanced simulator, model checker, and refinement checker for concurrent and real-time systems. Before I show you the tool, I need to define a problem that we'll later use the tool to solve. For that, I've chosen a classic bridge crossing problem. In this problem, people must get from the left side of the bridge to the right side of the bridge in the shortest time possible. However, there are three constraints. The first constraint is that only two people can cross the bridge at the same time, and the time of crossing is the time for the slower person. The second constraint is that there's only one lamp. And the third constraint is that they must use the lamp to cross the bridge. Simple deductive reasoning would tell us that the fastest two people must make the most crossings, and that the slowest two people must cross together. So first I'm going to have my fastest two people cross. Then I'm going to have my fastest person bring the lamp back. Then I'm going to have my slowest two people cross. Then I'll have my second fastest person come back. And lastly, my fastest two people will come to the other side. That gives us an elapsed time of 17, which is the fastest possible way to cross. This tool has 7 different models we can use to solve this problem. There's the communicating sequential process model, the labeled transition system, the probability, the probabilistic real-time system, the real-time system, or the timed automated model. I'm going to demonstrate how to solve it using the labeled transition system model. We have some definitions. 17 is the maximum amount of time we're going to allot. This is the speed of each of our players. These are our 4 players. 0 means they're on the left, 1 means they're on the right. This is our timer, which can go from 0 to 17. Our system is P1, which I'll show you in just a minute, and our goal is to get all 4 players on the right side within the maximum allotted time. P1 is a simple UML state diagram. In it, we have 2 states. We have the north side of the bridge and the south side of the bridge. And we have a labeled transition for each one of the possibilities. In this one, the queen crosses by herself. This one, the king crosses by himself, all the way up to the pairs, where at the top, the knight and the lady are both crossing at the same time, or the knight and the king are crossing at the same time. So I'm going to open up one of the transitions just to show you what it looks like. In this one, the knight and the lady are crossing at the same time, only if they're both on the left and the time of the slower person added to the cumulative time is less than the maximum. Provided they meet the guard condition, the knight and the lady will both be then on the right side, and the cumulative time will be increased by the amount of the slower person. Now we'll take a look at it in the built-in simulator. To solve this problem, the tool will walk through all the possible permutations in the entire game. So, for instance, the first move could be the knight and the lady could cross first, and then the knight could come back on the second move. Or another possible first move that would be the knight and the queen crossing first, and then the knight coming back. Or another first move could be the lady and the king crossing first. So you can see if we generate all the permutations of the entire game, it would look something like this. We've just effectively played the game using all possible moves, combinations of moves that there can be. Now we're ready for the verification process. The verification process will test to see if our system reaches the goal. The goal, again, was to get all 4 people on the right side within the max, which is 17. So when we start the verification, we select the goal that we want to verify, we click verify, and it tells us that it was able to do it, and it also gives us the path that took it to get 17. So it was the knight and the lady crossing first, the lady coming back, the king and the queen crossing, the knight coming back, and then the knight and the lady going across again. Now to verify that 17 was the fastest that we could cross, we'll come back and we'll set our goal at 16 to see if we can cross, if there's another path that can cross possibly in 16 moves. We click verify again, we verify our goal, and it says that that goal is not valid. We've now proven through an exhaustive search of all possible plays in the game that the fastest time is 17. Using this tool, there are 6 other ways we can also solve that same problem. I don't have time to show you those, but I'll show you a little bit about my favorite, which is timed automata. In timed automata, we have multiple systems that are all running at the same time, and they're communicating through these channels. Here's a take channel and a release channel. Take is comparable to someone raising their hand saying, I want to go across. Release is comparable to something saying, go ahead and cross. The timer process is simply a countdown timer that times out at the maximum time that we've allotted. The torch process mimics the torch going across the bridge, either with one person going in this path or with 2 people going in this full path. And the last is the person making the move. This one's saying, I want to cross. This one's saying, go ahead and cross. Now we're on the other side. We want to come back. This one's saying, I want to come back. And this one's saying, go ahead and go back. That completes the demo of the process analysis tool.